Hey guys, what's up? I'm Tim Laderack, and today I'm going to help you answer the question, how much do I need to save for retirement? Now, in order to get that answer, we're going to review this in two parts. The first part, we're going to get into Excel, into the nitty-gritty, and look at the future value calculation. It's a very powerful calculation that's going to be able to answer this question as well as many others, so it's good that we learn that now. We'll also look at the important building blocks that go into that calculation that make it so powerful. In part two, which will come in the next video, we'll use that future value calculation specifically for the retirement answer. How much do I need to save in total? And then also how much do I need to save per month? And we'll look at a tailored answer for you specifically on how much do you need to save. So if that sounds good, then buckle up and get ready because we're going to dive in. We've got a lot to cover. All right, so here we are in Excel. The first thing that I want to stress to you guys is PEMDAS, order of operations. Yes, it came back again. You're welcome. So order of operations, parentheses, exponent, multiplication, division, addition, and subtraction. Remember that because that's going to be key in order to get these calculations to work appropriately. The next we're going to do is the future value calculation. So for future value, you're going to need a few key things. You're going to need the interest rate, you're going to need periods or the number of time periods, you're going to need payment, how much money is going into the investment account each period, and then you're going to need the present value, how much is in there now. If it's zero, easy day, it's zero. Hopefully it's not, but if it is, that's okay. We got time. All right, so that's future value. These are the key building blocks in it. So for interest rate, we're going to keep things simple. We're going to assume a 7% market interest rate for this calculation. So I'm going to put 7. I already had this as a percentage, but just remember, when you do percentages in Excel, it has to be expressed appropriately with decimals. So 0.07, periods. It's going to be number of periods, and we're going to keep it in months because when we talk about retirement accounts, they accrue interest every month. So we have 12 months in a year, right? And let's just say we're going to do 20 years. So we want to save money over the next 20 years, and there's 12 months per year. So that's going to be 12 months per year times 20. Now, if you don't know how to do this already, to get a calculation like this into a cell, you just put the equal sign, like I did, equals 12 times 20, enter, that does the calculation for you. Easy day. You could also just put 240, hand type it in, but Excel, if there's any kind of calculation, Excel can do it, most likely. So do the equals 12 times 20. Next we have payment. How much is going into the account each month? Let's just say we're going to say $500 a month. So 500, easy day. I'll go over these in a second. Present value, we're just going to say the present value is 0. All right, so I already have this in here, but I'm going to show you how to calculate it out. So let me delete. So in order to get future value, put your equal sign. Remember to start every calculation with the equal sign. You do equals FV for future value. You see, as I was typing this in, there's a whole bunch of functions in here that it can do. So I'm just going to do FV for future value, because that's what we're working on now, parenthesis. So this is telling Excel, run future value, and then parenthesis, here are all the values that go into all the building blocks that you need to come up with the future value. So building block 1 recovered was the interest rate. Remember, rate, interest rate. So this is the interest rate each period. Now, you're going to have to give me a liberty on this. Interest rate in general, when you hear an interest rate, 7%, you can get a 3% CD if you're lucky. You can get interest rate on a mortgage loan, 3.5, 4.0. That's going to be interest per year. So we don't want that, remember, because we're doing monthly. So you're going to do in your interest rate divided by 12. comma, move on to the next building block. We're dividing by 12, so we can get per month, right? Yearly interest rate divided by 12 months in a year. That's interest per month. And then we move on. nper, number of periods. We've already got that calculated out in months. Easy day, comma, move on. Payment. Again, we already have our payment in there per month. Click on the cell, comma, move on. Now, why am I clicking on these cells instead of just writing in the numbers? Well, I could do that. Instead of doing C8, I could do 500. And that would give me the same calculation for this cell at this time. But you'll see that when we move down in the future, it's good to have these building blocks programmed in there as the cell number, the reference cell, so that we can go in here and easily change. So like say $500, say you wanted $600, you'll be able to see you can change that 500 to 600 and it will automatically change your future value cell. Whereas if you had just typed in 500, you'd have to go back into the future value calculation, change 500 to 600, and then calculate. So that's why I do reference cells. So reference, payment, comma, move on. Present value, we don't have a present value, it's 0, but we'll still do the reference cell, and that concludes all the building blocks that we need. So we'll end parenthesis, enter, and there's your future value. Now why is it red? That's because I missed a key point to tell you. And that's why I said I would go back later to cover this. So when you're investing money into an account, you have to make the value negative in your calculation. Now it may seem counterintuitive because you are earning money, like you're putting money into an account, you're saving money, should be a good positive thing. But for the calculation to work, whenever you put money into an account and you're not physically holding it, you're putting the money into the account, it's going into an account, it's invested, and so therefore has to be negative for the calculation to work. So we're going to go in here and see purple, C8, we're going to make that negative, and there we go. Now we have a positive amount in our account. So now we have $260,463.33 at 20 years. So if you were to save $500 per month for the next 20 years and you get a 7% interest rate, this is how much money you would have in that retirement account. That's decent. That's not very much, but for a lot of people that's really good. So if we can just get them to save $500 per month. So now how much of that, if you were curious, is from money that you put in, the $500 every month? How much did that accumulate? Say if you were to put it into a bank account that earns essentially no interest. So we can do a calculation equals 500, right? And you saved it over 20 years. And there's 12 months in a year, 120,000. So you essentially banked $120,000 of your own money, but at the end of 20 years, you have a total of 260,000. So if we do that math, that 260 minus the 120, you get $140,000 in interest. This is why saving in retirement accounts is so important, because look at that difference. If you had just put it into a regular bank, you would have gotten $120,000, but because you invested that money, you now have $260,000. That's the power of compound interest. That's great. So now remember what I was telling you about changing these values. So now we can do 600. If I were to save 600 per month, now you can see my value goes up even more, 700 per month. It goes up even more. So now you can see like how much would I need to save per month starting now at 7% over the next 20 years to get $1 million. Let's just try 1,000. Nope. 1,500. Nope. 2,000. There we go. All right, so we need to save $2,000 a month in an account that earns 7% interest each month or each year, and we would get over $1 million in our retirement account. All right, so next we have sticky cells. Another important thing I want to show you, as well as series, and these will help you create tables. These are very powerful tools to just have in your tool belt. So let's start with that. So to start with our table, we have year. Say you want to know the total value each year, and it goes up each year. How much interest you have earned total each year, and then how much investment you have in that account each year. Remember I was saying you put that $500 a month, that's what this is going to be. This is how much is coming from interest to get your total value. So let's put this back down to, we're doing $500 per month. Now, this is just the future value. I'm going to take these out so I can show you how I do this. Okay, so now we're going to fill in a table. So we have year, total years, we're going to do 1 through 20. We have total value each year. We're going to have interest, total accrued interest over the years, and then total accrued investment over the years. So we're going to start filling out these years. So I could just go down 1, 2, 3, 4, but to make things easy, Excel has a built-in feature where you can click on your initial cell and drag down that corner. You see what I'm doing? Here's this corner. Drag down, and it will autofill. Now what you can do is this little box, autofill options, fill series. Boom. Look at that. So instead of going through and typing out each one, it automatically did that and makes it really quick. We'll just keep doing that until I have 20. There, 20. All right, so now total value. So now let's go, we're going to do future value, right? So equal, how do you do future value? Equals FV, parenthesis, rate's going to be the same, nper. All right, so number of periods. Well, we're going to start with, since we're doing our table, we're going to click here in sets. We're going to click 1 times 12, right? So 1 year times 12, 12 months. And you're going to see we're going to be able to drag this down, and it will be able to fill in 2, and then 3, and then 4, and then 5 into each subsequent future value calculation, so you can see the future value after each year. All right, so next you see bolded payment. Payment's going to be the same. Negative, remember negative payment, because it's going into an account. And then present value, which is 0. All right, so this is going to show you the importance of sticky cells. So if I just press, we're going to get a good answer, right? Remember this was the value after 1 year, $6,196.29. Now if I were to go down and try to do the trick I did over here and fill this in, watch what happens. Errors galore. See, error. Now why? Look at value, or year 2. Look in your value box here, or your function box. Look what it did. So here it brought 2 down. Remember it was at 1, now it's 2. But look what it did here. It brought all these down. Remember blue, look at blue and this one. Blue is interest, right? Look here, blue is now periods. Now I would love for it to have 240% interest, but this is not helpful for our calculation. So in order to make this work, we make these sticky. So I'm going to undo, go back here, go into my function box. Now, which ones do I want to stick? I want percentage to stick, so blue. So I'm going to put a $sign in front of the column C, $C. I'm going to put a $sign in front of the row 6. So now I have $C, $6, $C, $6. This is going to stick now. I need purple to stick. That's the payment. $C, $8. I also need the green to stick. $C, $9. I don't want red to stick because when I drag this down, I want red to go with it. Same answer. Now watch what happens. Boom. That's more like it. That's more realistic. Look, 6, 12, 19, 27, 35, 44. That's going up more like it. So I'm going to continue that down. Now look at that. At year 20, this is how we know it worked. 260, 463, 260, 463. Okay. Now let's say you want to know how much interest and investment you have in that account after each year. So we'll start with the investment, right? So we had equals 500 times 12 months in a year times year 1. enter. Now, what did I miss? I missed making it sticky, right? Because if I were to drag this down, remember all these cells would go. We want the year to go, but we don't want the payment to go. So come back here, we'll make this sticky, $C, $8, and now we can drag it down. Boom. Now we're going to do interest. So interest is simply the difference, right? So it's going to be your total value is made up of the principal and the interest. So for this, we have just equals the total value minus the investment, boom, $196 of that and 29 cents is interest. Now we're going to drag this down, and you can see now here, remember we set up here $140,000 in interest over the life of that investment. Here we see again $140,000. So now you can just see each year how much total accrued interest and investment you have in that account. And you can see somewhere around year 18, the total interest surpasses the investment, how much money you physically put in. So that just shows you the power of compound interest. Now, if you wanted to, you could say, well, what if I had saved for 30 years at 500? What would happen then? So you can highlight these cells, and because we've appropriately stuck the cells, the building blocks in these formulas, you can just drag this whole thing down. We'll do this same trick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look, at year 30, look what it did. It brought it all down. So for the first 10 years was 86,000. The next 10 years, 260,000. And then the next 10 years, 609,000. So our curve is going like this. Exponential growth. That's the power of compound interest. So that's what I wanted to show you. So then these are the building blocks we're going to use to determine how much you need to save for retirement. Wow, that was a lot. If you made it through, good job. Stay tuned for part 2. Don't forget to subscribe so that you can be first to know when it does come out, so we can wrap this up and find out how much you need to save for retirement per month and in total. And don't forget to like. Thanks.